right, for C, we have y equals x squared minus 2. We're noticing that the coefficient here is positive, so we're going to be opening up. So the domain, well, first actually let's graph this thing. It's just the regular parent graph, not stretched or compressed, and it is shifted down 2. So instead of my my vertex being at 0, 0, I'm at 0, negative 2. There's no stretch or compression, so I can just go up and over as I usually do. So 1 and 1, and go back to the vertex, 2 and 1, 2, 3, 4. And I think on this one we can get to 9. 3 and 1, 2, 3, 4, 5, 6, 7, 8. Hello. That's great. Oh, no. Gotta draw this one, and then I gotta draw this one. Alright, so this is how I would graph it. So the domain is always going to be x is an element of the reals. We're saying range y is greater than or equal to negative 2. Y is an element of the reals. The axis of symmetry, we're not moving left or right, so it's still x equals 0. The vertex is going to be at 0, comma, negative 2. The maximum or minimum, we have a minimum because it opens up, and that is going to be at y equals negative 2. The x-intercepts, now this one is a bit of a tricky one, okay? We have our x-intercepts here and here. It doesn't cross over at a super nice number. I'm not going to worry about that because we don't quite have the skills to figure out what they are. So if it's not clear, you don't have to write it. And don't say none because there clearly are some. But they're actually irrational, okay? They're going to be the square root of something. The y-intercept, though, is very clear. It is at y equals 0. So when you see something does not cross the x-axis, oh, I should put in my, this is 1 and this is 1. When it does not cross at a nice value, don't worry about stating them at this point. You will get to a point where you can state them, but now is not the time. So, D. I am noticing that it's still going to be opening up because I don't have a negative here. It's going to be opening up and it's going to be shifting left 1. So I'm going to have my x and my y. I should have always been doing that, just heads up. And I know that it's going to be, this is where the parent graph is, or the mother function, and I'm moving to the left one. So this is my new vertex, over 1 and up 1, over 1 and up 1, over 2 and up 4, over 2 and up 4, and that's all I can fit on my graph. So I'm going like this. Don't forget your arrowheads. Oh, well, that was sloppy. There we go. Domain for this one is going to be x is an element of the reals, because even though it's shifting over left 1, it's still going to go to infinity in both directions, so don't worry about that changing. The range is going to be y is greater than or equal to 0, and y is an element of the reals. Axis of symmetry, this is something that changes. Now, I don't want you to put a dotted line like I did, because that symbolizes asymptotes, which we will be learning about later on in the course, but this right here is our axis of symmetry. It does shift over 1. So x equals negative 1. The vertex is going to be at negative 1, comma 0. We have another minimum, and it's going to occur at y equals 0. X-intercepts, this one's cool. There's only one of them, and it is at, the x-intercept is at negative 1. The y-intercept is at 1. Another way that we could write this, just a heads up, you can say or, you can go negative 1, comma 0. And you can write this one or, and I saw this on mastery checks and I liked it, at 0, comma 1. We're good. This one, we're going to keep it positive. We know that it's moving to the right because it's subtraction happening there. So moves right 4, and still it's the A is positive. The A in front is just 1 in this case, and it's positive, so it opens up. So I'm going to put my scale 1 and 1, label my X and my Y. And instead of my vertex being at 0, 0, we're going to be moving it over 4. And I can just do the exact same thing because there's no stretch factor. The A is just 1. So over 1, up 1, over 1, up 1, over 2, up 4, over 2, up 4. And I can draw this. Whoop, whoop. So the domain is going to be at X is an element of the reals, Y is greater than or equal to 0, comma, Y is also an element of the reals. The axis of symmetry is going to be at X equals 4, and the vertex is going to be at 4, comma, 0. We again have a minimum, and the minimum occurs at Y equals 0. The x-intercepts, there's only one of them, and it occurs at 4, comma, 0. Or you can say x equals 4, it doesn't matter to me. Now here's the y-intercept. We don't see it. So what we can do is we can do a little bit of work on the side. Y-int, that means that x equals 0. So I'm going to substitute into my equation x equals 0. So y equals 0 minus 4 squared. So then y equals negative 4 squared. Negative 4 times negative 4 is going to be positive 16. So my y-intercept occurs when y equals 16, or we can have 0, comma 16.